CamIO, an audio-based AR audio labeling app for visually impaired users. I'm James Coughlin, and my collaborator is Brandon Biggs. We're at the Smith-Kettlewell Eye Research Institute. Before I talk about the software we're developing or show you the demo, I want to give some motivation for what we're doing. The motivation is people with visual impairments who have trouble accessing a lot of physical objects. These objects could be relief maps, 3D models. They could be 3D printed ones or physical models, appliances with lots of knobs and switches, tactile graphics or other documents. So often Braille labels are added to tactile maps, graphics, and 3D models as a way of improving the accessibility. But Braille has some big limitations. The first limitation is that there's only so much space for Braille on the object. It can interfere with being able to explore the object's surface. And of course, not everyone reads Braille with a visual impairment. So a general solution is to have audio labels. So each landmark of interest, what we call a hotspot, can have a specific audio label. And the idea is that a person can explore the object naturally with their hands and then trigger hotspots when they're interested. So this is enabling an audio haptic interaction with the object. And the question is how to do this inexpensively. So this is where CamIO comes from. CamIO stands for Camera Input Output. And the idea of the CamIO approach is to use AR and computer vision to create virtual audio labels. And there's been a lot of past work on this approach I won't go into, just to mention a few names here on the slide. In our approach, we've created an iOS app that sees where you're pointing on a 3D object. And the pointing currently is done using an inexpensive stylus with barcodes on it. And the stylus could be made out of paper or cardboard or wood. The object of interest is mounted or attached to a fiducial board. This board has a bunch of barcodes on it. And the board is what allows CamIO to estimate the object pose. And then hotspots are placed virtually on the object. The location of the stylus tip is estimated in 3D. And then anytime the stylus gets close to a hotspot, the hotspot information is read aloud. So the advantages of this approach, pretty much any rigid object can be used with CamIO. Just a minimum of customization is needed. You have to print a board out, you have to mount or attach the object to the board, and really the only costly part of the CamIO approach is the iPhone or iPad that you need to have to run it. As shown in this picture, a tripod can be helpful, but it's not always necessary, and we'll see some variations of this. Here's how to use CamIO. The important thing is that the stylus has 4 sides on it. One side is called the writing side. This is the side in the figure there that has the red tactile dot, and that's for creating or writing new hotspots. The other 3 sides of the stylus are reading sides. They're for reading hotspots that already exist. And it was important for us to make the app work so that both reading and writing hotspots would be accessible to someone with a visual impairment. So a few sounds. This will help you make sense of the demo video. The cricket sound that the app gives out means the camera can't see the board clearly. And so something will have to be moved. Maybe you have to aim the camera a bit differently, or perhaps the hand is in the way between the board and the camera. Repeated double clicking, that sound indicates that the writing side of the stylus is visible to the camera. And when that happens, that means that the app is ready to record an audio label. And when it comes time to finding an existing hotspot, verbal feedback is available. Left, right, up, down, back, forward. This is spatial guidance telling you which way you need to move the stylus tip to get closer to the hotspot. Okay, just a bit of background on the demo. We created this demo showing a blind user running CamIO with VoiceOver on an iPhone 8. And there are 4 main tasks in this demo. It's a very short and simple demo. The first part is to create a model named Airplane. The second part is to aim the camera properly to make the cricket stop. Next, create a hotspot at the tail of the airplane. And then the last part is just to find the hotspot that was just created and to hear it read aloud.
Add model button. Alert. Add model. Text. Braille screen input. Screen away mode. A I R P L A O N N O N E. Portrait. Save button. Model list button. Start recording after the beep.
Tail.
Recording is finished. Playback to verify.
Tail.
Hotspot 0. Back, 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 right, 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 forward, 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 back, back, back.
Tail.
Here we talk about two recent papers on CamIO. The first one is a co-design and user study with 6 blind participants. In the co-design, we asked the participants what their ideal solution was to make objects more accessible. And they said that their ideal solution, by and large, would entail both audio and Braille labels. In the user study, we had participants use CamIO on 3 different objects shown here. One is a biological cell model. The other is a tactile map showing about 5 by 5 city blocks and a microwave oven. And so the participants were able to use CamIO to create new labels on these objects. And also in the last picture on the bottom right, you can see that a participant is wearing a Google Cardboard, and they're putting the iPhone running CamIO in the Google Cardboard. And this allows them to not worry about having the iPhone in a tripod. It does mean that they have to consciously direct their gaze towards the object. And I think for some users that might be acceptable, for others not. And of course, in the top figure, you see a gooseneck cell phone holder, which I've found easier to use than a standard tripod, easier to adjust. So the next study introduced the spatial guidance feedback, and we tested this with 4 blind participants. And in this study, we had 10 hotspots on a toy fire truck shown here, and we asked people to find hotspots with and without guidance. And so in the case of without guidance, basically there was no audio indicator until the stylus got very close to the hotspot, in which case the hotspot was announced. And not surprisingly, the guidance up, down, left, right, back, forward made it much faster to find a hotspot. Okay, so a bit about the future plans for CamIO. The guiding principle that we're keeping in mind is to add options for CamIO, not to subtract them. Lots of different people are going to have different needs depending on their applications and so forth. So we've really tried to target CamIO at people who may have an iPhone, not necessarily the latest, greatest model. We're well aware of things like ARKit 3D object scanning, and that might eliminate the use of the board in many cases. Of course, the newer mobile devices do hand tracking, and it should be possible to eliminate the stylus in other cases. So these are pretty obvious directions to move in, but just to keep in mind, depending on circumstances, a board or stylus may still be useful or necessary. So for instance, the ARKit 3D object scanning works well when the objects have lots of visual features, but if you have something like a very plain coffee mug with a dull finish on it, it may not have enough visual texture to permit the object scanning to work. And then for the stylus, it may be that for some people it's easier to hold on to something, particularly if they're trying to create a new hotspot. For others, it will be easier to just use their fingers. And of course, the other really obvious point is that there are all sorts of XR devices, wearables, glasses, that would be great for CamIO. The reason that we haven't prioritized them is we're trying to make an approach work with standard iPhones that lots of visually impaired people have, and the XR devices are going to take a little bit of time to take off. Another particular project that we're working on involving CamIO relates to the Magical Bridge Playground in Palo Alto, California, and this is an accessible playground that's targeted at kids and adults with differing abilities, and there's a picture in the lower left. And so Brandon Biggs is creating a 3D scale model of the entire playground, and on the right there's a little picture of a 3D model of the slide mound that's sort of in the center of the photograph. And the idea is that there'll be a bronze installation of the 3D model of the playground, and people who visit the playground can, point a stylus or something at that scale model and get information about what they're pointing to. And this is part of a larger sort of project that he's conceived of for a larger XR experience in the playground. You could explore it offline, for instance, in some sort of virtual reality, etc. And then when you get there in person, you can explore the 3D model as well. Some acknowledgements. First, we'd like to acknowledge Huiying Shen, who's done all of the iOS app programming, which is a tremendous amount of work. Also, the many participants who helped us out, not just with the studies in this presentation, but some of the earlier CamIO studies. They've been very helpful. And funding from NIDLR, the NIH, and from Smith-Kettlewell. And I'll just leave this page up here, more about CamIO, a link to the project page, which includes links to pubs. And if you're interested in beta testing, please send an email to camio@skia.org. Thank you very much.